Imagine paying millions of dollars just to dig up a bustling city block,
Yeah.
right? Like stalling traffic for 6 months, pouring just metric tons of concrete, and rerouting these massive high voltage lines, also you can, plug in a car.
Yeah, it's an absolute nightmare for urban planning.
Right. And then imagine the realization that you could have completely bypassed that entire headache by just using the lamppost that was already standing right there on the sidewalk.
Exactly. I mean, we've spent a century really conditioned by this traditional gas station model. We view vehicle energy as this heavily rooted destination, right? Something you absolutely must travel to, built on these deep trenches and massive local grid upgrades.
Yeah, the old way of doing things.
Right. But, EV adoption is surging so fast right now that relying solely on that legacy model is, well, it's creating a massive infrastructure bottleneck. The centralized grid simply cannot handle the demand of pouring concrete every time we need a new charger.
Which is exactly why we are pulling apart some really fascinating intelligence for you today on the deep dive. We've compiled a big stack of materials for this one. We've got municipal strategy call notes from Massachusetts, press releases from mobile charging startups like BeeCharged EV and Door Energy.
Yeah, those are really interesting.
Definitely. And we also have a technology catalog from the Massachusetts Clean Energy Center, plus some fresh research from Caltrans out in California. So the core mission of our deep dive today is to really look at how innovators are untethering charging from the grid entirely.
It's a huge paradigm shift.
It really is. We are moving away from the assumption that EV chargers have to be these fixed, permanent, heavily grid-dependent monuments.
And the initial phase of this shift isn't even about going completely off-grid. It's more of an exercise in urban camouflage, really.
Urban camouflage. I like that.
Yeah, because the startups in these sources, they're looking at the existing streetscape and basically asking, how do we hack what's already here? Because trenching new lines is, frankly, the single biggest barrier to urban electrification.
Okay, so let's talk about that street-level hack. Our sources highlight this company called VoltPost, and they are literally repurposing streetlights, turning them into charging stations. But wait, when I look at a lamppost, I think, well, that's just enough power to run a light bulb,
Yeah, exactly.
How on earth do you charge a 2-ton vehicle off of a light bulb circuit?
Right. So a standard lamppost operates at about 100 volts. And you're spot on, that is nowhere near enough to provide meaningful range quickly.
Okay, so what do they do?
Well, to charge an EV efficiently in a public space, you really need level 2 charging, which requires 240 volts. So what VoltPost does is they work directly with the local utility company to internally upgrade the wiring of that specific post.
Oh, I see.
Yeah, they upgrade it to 240 volts, and they handle that entire upgrade as part of their deployment package.
So they essentially swap the guts of the lamppost.
Exactly.
And looking at the Massachusetts strategy notes, it says they can actually fit 2 to 4 chargers on a single post, which is wild. But the detail that really stood out to me was the cable management, because they use these retractable cables. Like when you unplug your car, the cord just zips right back up into the post.
Which is crucial because sidewalk clutter is a major, major municipal hazard. I mean, if you have permanent cables just lying across pedestrian walkways, you're practically inviting tripping lawsuits.
Oh, absolutely. And vandalism, right?
Yeah, that too. Enclosing the mechanism solves both of those issues. And the really clever part is that they install internal utility meters, so the power drawn by the vehicle is tracked entirely separately from the power keeping the streetlights on.
So the city isn't footing the bill for your commute.
Exactly. The city isn't subsidizing you, and the streetlights don't suddenly dim when you plug in your SUV.
That's smart.
Yeah.
And since they've already gone through the trouble of securing a 240-volt connection on, a piece of prime city real estate, VoltPost is actually planning to add 5G nodes, air quality sensors, and even security cameras to these posts later on.
Yeah, it turns a single-use piece of infrastructure into a multi-use urban utility hub.
But, that only solves the problem if you happen to park next to a municipal streetlight.
Right.
What happens on a residential block where the infrastructure is mostly just private homes or apartment buildings?
Well, that introduces a really cool model used by another company in our sources called It's Electric.
Okay.
Instead of public lampposts, they utilize private buildings to power public street chargers.
Wait, how does it work?
So most buildings, whether they're commercial or residential, have this excess electrical capacity built into their panels that they just never use. The sources estimate the spare capacity is usually sitting around 40 amps.
Gotcha. And just to put that in perspective for you, 40 amps is roughly the dedicated circuit you'd need to run, like a large electric oven or a massive central air conditioning unit.
Right, exactly.
So its electric is basically tapping into that unused oven capacity that's just sitting behind the brick wall.
They bring that excess capacity out to a charger on the curb, and the financial incentive is the real engine here. The building owner pays absolutely nothing for the installation or the hardware.
Zero upfront costs.
Zero. And in exchange for hosting that connection, the property owner actually receives 20% of the revenue generated by drivers who pay to use that charger.
Wow. It's essentially like running a highly sophisticated extension cord out your window for your neighbor and collecting passive income on it.
Yeah, that's a great way to put it.
But let me push back for a second because I instantly see a massive accounting nightmare with this.
Oh, really? How so?
Well, if I manage, say, a green certified commercial building or a municipal office that's aggressively trying to lower its carbon footprint, having 50 random cars pull heavy power through my building's meter every single week is going to artificially inflate my emissions data.
Oh,
It
absolutely.
would make my building look suddenly wildly energy inefficient.
It would ruin a building's sustainability metrics practically overnight. But the sources actually detail how its electric bypasses this exact problem. They don't just piggyback on the building's main utility bill.
Oh, they don't?
No, they use a specialized software provider called Switch, and they establish a completely separate direct account with the utility companies specifically for that curb charger.
Okay, so the data is completely bifurcated at the source.
Exactly.
Yeah.
The physical electricity flows through the building's infrastructure, sure, but the financial billing and the carbon accounting are routed directly to its electric.
That's incredibly clever.
Yeah, so the host building's official utility bill and their emissions profile remain totally untouched. It requires some really complex back-end software, obviously, but it shields the property owner from any liability.
And speaking of liability, the sources say they also use completely detachable cables for this.
Right.
Like you actually keep the charging cord in your own trunk, and the curb unit is just this sleek blank socket until you plug your own personal cord into it. Again, virtually eliminating vandalism and sidewalk clutter.
Which is huge for cities.
Right. But let's look at the friction here, because these municipal notes from Massachusetts show that deploying these hacks isn't always a seamless stream. National Grid ran a pilot program in Melrose, Massachusetts, testing out pole-mounted chargers.
Yeah, the Melrose pilot.
And the headline was fantastic, right? The installation was 70% cheaper than traditional ground-mounted stations.
I mean, a 70% capital expenditure reduction is just revolutionary for city budgets.
It is. But the pilot also exposed how severely outdated local bureaucracy is. The physical hardware was cheap and easy to install, but the administrative process was grueling.
Oh, the red tape.
Exactly. They encountered major delays with third-party attachment protocols. Getting permission just to put hardware on a utility pole required exhaustive site surveys. They had to negotiate complex insurance liabilities, and they were hit with recurring licensing fees.
Yeah, it's a classic case of the technology vastly outpacing the zoning laws.
It really is. It's this wild culture clash between Silicon Valley tech pacing and local city hall permitting. And it's not just the bureaucracy either, it's human behavior.
Oh, for sure.
The notes from Somerville, Massachusetts highlight this perfectly. They launched public chargers and initially made them totally free to use.
And we all know how that goes.
Predictably, it was a total disaster. People treated the public chargers like personal VIP parking spots. They'd just leave their fully charged cars plugged in all day, blocking anyone else from using them.
Right, because if a resource has no cost, it has no urgency.
Exactly. So Somerville had to pivot to what they called the Charge for Charge program. They implemented a fee of 25 cents per kilowatt hour, which effectively just covers the city's base cost of the electricity.
So they aren't even trying to make a profit.
No, not at all. The primary purpose of the fee wasn't profit. It was behavioral economics. By keeping the meter running on a driver's credit card, they artificially enforced turnover. Once your battery is full, you are financially motivated to move your vehicle.
Which just proves that building the infrastructure is really only half the battle, right? Managing how humans interact with it is the other half.
Totally. But, this urban hacking lampposts and buildings, it still relies on a functioning local grid.
Right.
What happens when you leave a city? Or worse, what happens when a natural disaster knocks the grid completely offline? This brings us to a massive leap in our source material. the shift to 100% untethered mobile charging.
This is where things get really sci-fi, because the legacy roadside assistance model for an electric vehicle, it's just incredibly brute force.
Oh, it's so clunky.
It is. If you run out of battery on the highway right now, the current protocol is to dispatch this massive diesel-powered flatbed tow truck. You wait for an hour or more, the operator winches your heavy EV onto the bed, and they literally haul you miles away to a stationary charger.
I always think of this like building an expensive permanent water pipeline out to a marathon runner instead of just handing them a water bottle as they run past.
That is a perfect analogy. It is a wildly inefficient use of resources.
But the startups in our stack are operating like an Uber Eats for power banks. They bring the electricity directly to the vehicle.
Yeah, look at the operational model for BeeCharged EV. They just recently secured $7 million in funding, and they're allocating nearly half of that specifically to mobile charging equipment.
That's a serious investment.
Yeah, they're rolling out a commercial service in major markets: Miami, Los Angeles, Boston, San Francisco, and they're partnering with a mobility platform called Urgently. Their fleet literally drives a level 3 ultra-fast charger right to stranded drivers.
Let's clarify that for a second, because that's important. Well, we talked about level 2 earlier, right, which takes several hours to fill the battery.
Yeah.
But BeeCharged is using level 3, which is DC fast charging.
Right.
How do they even fit that on the back of a response vehicle?
So level 2 charging relies on alternating current, or AC, which requires your car's onboard converter to translate that energy into direct current, DC, for the battery.
Okay.
And that translation takes a lot of time. Level 3 charging skips that middleman entirely. It pumps high-voltage DC power directly into the battery, completely bypassing the car's internal converter.
Oh, wow.
Yeah, and shrinking that technology down so it can be mounted on a standard response truck means they can deliver massive amounts of energy in minutes, not hours.
And their ambitions are massive, too. The press release says they're aiming for a 1 million member subscription network.
It's ambitious.
It is. We also have a company called Door Energy in the sources, and their hardware takes this whole off-grid concept even further. They manufacture these trailer-mounted chargers that require zero grid connection.
The engineering specs on Door Energy's units are just staggering. They can deliver up to 420 kilowatts of DC power and hold up to 420 kilowatt hours of storage on a single trailer.
That's insane.
And they do this with zero emissions. They aren't hiding some loud, dirty diesel generator inside the box. It is pure battery storage.
Okay, but what does 420 kilowatts actually mean in a real-world scenario? Like, give us a sense of scale.
Sure, to put 420 kilowatts into perspective, a typical central air conditioning unit in a large house might pull, say, 3 to 5 kilowatts at peak operation.
Okay.
A typical home outlet provides less than 2 kilowatts. Door Energy is effectively driving a localized power plant right up to your bumper. Delivering 420 kilowatts means they are maxing out the charging capability of almost any EV on the market today.
So, just to push back slightly on this whole mobile rescue concept, the fear is always that you're going to be sitting on the side of a blazing hot highway for 3 hours while a trickle charger just slowly drips 5 miles of range into your car.
Oh yeah, range anxiety is real.
Right. But at 420 kilowatts, we aren't talking about a trickle, are we?
Not at all. At those speeds, a driver is receiving a massive injection of range in like 10 to 15 minutes.
Oh.
It's a rapid rescue. You get enough juice to safely reach your destination or the nearest permanent charging hub, which completely eliminates that hour-long wait for a tow truck and the super awkward ride to a station.
The resilience factor here is also huge. The Massachusetts notes mention a company called SparkCharge, which actually proved this concept during a real crisis.
Right, in Texas.
Yeah, when Hurricane Beryl decimated the power grid in Texas, all the permanent chargers were totally dead. So SparkCharge deployed their portable off-grid battery units to provide emergency charging. And because these mobile units can recharge themselves via solar networks, they become an absolute lifeline when the centralized grid just fails.
It really changes the definition of critical infrastructure. But rescuing a stranded commuter or providing disaster relief, that's just the tip of the spear. Oh yeah. The real stress test for this untethered grid is happening on an industrial scale right now. Government agencies and massive commercial fleets are utilizing mobile charging as a strategic loophole to bypass grid limitations entirely.
Okay, so if you're wondering why your local delivery companies or, city services haven't fully electrified yet, it almost always comes down to grid bottlenecks.
Yep.
The Massachusetts Clean Energy Center notes call this facility upgrade delays. Let's say you own a fleet of 40 commercial box trucks. You can't just plug 40 massive commercial vehicles into the wall of your warehouse.
Right, because the power demand of 40 commercial EVs requires a massive infrastructure overhaul. You need local transformer upgrades.
And those aren't quick.
No, not at all. A transformer steps down the high-voltage electricity from the main grid into a usable voltage for a facility. Upgrading a municipal transformer to handle a commercial EV fleet can take years. Years of permitting, environmental reviews, and utility construction.
Which is time these fleets just don't have, because state mandates are forcing them to electrify right now.
Exactly.
To solve this, the Electric Vehicle Infrastructure Coordinating Council awarded Mass CEC $38 million. And a major portion of that is funding a program to electrify 4 medium and heavy-duty fleets. We're talking classes 3 through 8, the big commercial trucks, by February 2026.
That's a very tight deadline.
It is, and they are doing it almost entirely with mobile charging stations.
Because mobile chargers instantly bypass that transformer bottleneck.
Yeah.
But they also solve another massive real estate problem: facility ownership.
Oh, right, the leases.
Yeah, a vast number of commercial fleets actually lease the land their depots sit on. If you hold a 5-year lease on a parking lot, you cannot financially justify trenching the asphalt and pouring hundreds of thousands of dollars into permanent concrete charging infrastructure that you will inevitably have to leave behind.
It makes no sense.
None. A trailer-mounted mobile charger completely eliminates that stranded asset risk. When your lease is up, you just hitch your charger to a truck and drive it to your new lot.
It's brilliant. And the Mass CC documents refer to another huge benefit here called right-sizing. This is such a smart concept.
It really is. Before a fleet commits to pouring concrete, they can bring in a mobile charger to test their exact energy needs. It's like, setting up a pop-up shop to test the market before signing a 10-year lease on a retail storefront.
Exactly.
It allows a massive fleet to beta test their operational energy draw in the real world, ensuring they don't overbuild or underbuild their permanent infrastructure later.
And the hardware enabling this fleet-level charging is incredibly sophisticated. The Mass ETC catalog features a company called Electric Fish, specifically highlighting their 350 squared model.
Tell me about this one, because the specs look wild.
It is. This is a containerized, trailer-mountable AI battery system. It packs 400 kilowatt hours of storage, but its true innovation is how it acts as a buffer.
Okay, explain the buffer concept for us, because the catalog says it can integrate with standard 208-volt or 240-volt connections without any transformer upgrades,
Right.
but it somehow outputs 350 kilowatts.
Right.
How does it multiply the power to like that?
Think of it like a massive water tank connected to a standard garden hose. The garden hose, representing the low-voltage grid connection, slowly trickles water into the tank 24 hours a day.
Okay.
The tank just quietly stores it up. Then, when a heavy-duty truck pulls up, the tank opens a massive floodgate, blasting out 350 kilowatts of power instantly.
So it's hoarding the power and releasing it all at once.
Exactly. It slowly sips from the grid, but rapidly dispenses to the vehicle. That 350 kilowatt blast equates to adding roughly 20 miles of range per minute to a commercial truck.
20 miles range a minute from a system that doesn't require a grid upgrade.
Yeah.
That is phenomenal engineering. But if we are looking at this from a taxpayer perspective, let's consider the cost.
Always the sticking point.
Always. If you are a government agency buying fleets of massive trailer-mounted AI batteries, aren't the acquisition and maintenance costs astronomical compared to just building a permanent station?
That financial friction is exactly what the California Department of Transportation, Caltrans, is investigating right now. Yeah, our sources include a project brief for a Caltrans lifetime cost-benefit analysis on mobile DC fast chargers, and this is running through February 2027. Caltrans operates a massive fleet of emergency response and roadside assistance vehicles.
Right.
Currently, they are actively losing taxpayer money and operational efficiency because their fleet vehicles are just sitting at permanent stations waiting in line for an available plug to charge.
So the downtime is killing their efficiency.
Precisely. The study is rigorously weighing the upfront cost of acquiring these mobile batteries against the operational savings of keeping their critical response vehicles moving. If a mobile charger can drive to an emergency vehicle in a remote area with zero grid connectivity and keep it operational, the value of that uptime might far outweigh the cost of the battery.
That makes total sense. And the Mass C8 catalog outlines another financial model that mitigates that upfront cost entirely, which they call charging as a service.
Yes, this is a game changer. Commercial fleets and government agencies don't even have to buy these $500,000 batteries outright. Companies like Electric Fish offer leasing and charging as a service models.
So it's a subscription.
Basically, yeah. They supply the mobile unit, handle all the maintenance, and manage the charging software, while the fleet just pays a predictable monthly subscription or a per kilowatt hour rate.
That makes it an operating expense rather than a massive capital expenditure.
Exactly.
And the Electric Fish system includes a software layer called Stargazer AI. The catalog notes that this AI doesn't just monitor battery health, it actively bids the stored energy into lucrative grid services.
This is my favorite part.
How does a charger bid into the grid? That sounds crazy.
So the centralized power grid is constantly fluctuating, right? It needs stabilization during peak demand. Because the Electric Fish battery is bidirectional, the Stargazer AI monitors the energy markets in real time. If the local grid is stressed, say, during a heat wave when everyone turns on their air conditioning, the utility company will pay a premium for extra power.
Right.
The AI automatically sells the stored energy from the mobile charger back into the grid at that high price, generating revenue for the fleet owner.
Wow. So the fleet has a massive battery sitting in their lot that acts as a super fast charger when the trucks need it and acts as a localized profit-generating power plant when they don't.
Yep.
That fundamentally changes the math on the cost of ownership.
It absolutely transforms charging infrastructure from a sunk cost into an active revenue-generating asset.
So synthesizing all these sources, from the 240-volt lampposts to the 420-kilowatt trailers, what does this mean for you, the listener? If you own an EV right now or you're considering making the switch, the old anxieties are rapidly becoming obsolete.
They really are.
Your future is not tied to nervously hunting down a rare, working, permanent public plug. The infrastructure is adapting to find you. It is hiding in plain sight in the streetlights on your block. It's borrowing excess capacity from the office building you work in, and if you're ever stranded, a massive battery will literally drive out to meet you.
We are witnessing the death of the centralized gas station mentality. The rigid, concrete, heavy grid is dissolving into a decentralized, modular, and highly adaptable energy network. We are moving toward liquid infrastructure.
Liquid infrastructure. I love that phrasing. It moves and flows to exactly where the demand is rather than forcing the demand to come to it.
And if we follow the logic of bidirectional energy and mobile batteries to its ultimate conclusion, it leaves us with a rather profound possibility.
What's that?
Well, we've seen that mobile chargers can trade energy with the grid and drive to wherever they are needed. But modern EVs are basically massive batteries on wheels themselves. So how long until our own vehicles become part of this roaming, untethered fleet?
Wait, you mean the cars themselves becoming the infrastructure?
Consider a near future where you don't just use an app to order a mobile charger to your stranded vehicle. What if your vehicle is the mobile charger?
Oh, wow.
Vehicle-to-grid technology already exists. Imagine your EV holding the reserve power to keep your office building running during a blackout, or driving down the street to autonomously offload 50 miles of range into a stranded neighbor's vehicle for a premium. We aren't just untethering the charger, we are on the verge of untethering the entire power grid, turning millions of cars into a liquid energy network.
That completely changes the definition of what a car actually is. It's no longer just transportation, it's a node on the grid.
Yeah.
That is definitely something to chew on the next time you drive past a concrete gas station. Thanks for joining us to unpack all of this on The Deep Dive. We'll catch you next time.